Okay, this is January 2025 paper. Or question number one says this question is about experiments involving chromium ion compounds containing a small amount of uh, 3 sulfate. A small amount of chromium 3 sulfate means that it's gonna be chromium 3 and no Cr2SO4 3 because the charge for
Mm,
sulfate is 2 and the charge for chromium is 3, and then
mm,
in water, deionized water forming a solution containing a complex ion give the color of the solution form. Of course, chromium sulfate would be dissociating in the presence of water. It would be giving us the chromium 3 ions. We are supposed to know the color of chromium 3 plus. That's gonna be purple color. You need to know the color, okay? Like copper 2 plus, like nickel 2 plus, like chromium 3 plus. Copper 2 plus was, what was the color of copper plus 2?
wait, uh, copper plus two is blue,
Mhm. Yeah, that was blue. And what about nickel 2 plus
nickel two plus,
is green.
mm,
And chromium 3
green,
plus, yeah, chromium 3
uh,
plus is
purple.
purple. Okay. So
Yeah.
sometime you will see in the marking scheme, they will be writing lilac color. Sometime you will see violet color. Okay. So they are the same.
Hmm.
So state the formula. Oh, yeah, we told you. State the formula of the complex ion. They're asking the formula complex ion. What do you mean by the term complex ion? Basically, if we have chromium 3 plus, that is this, of course, water would be attracting this chromium 3 plus, or I can say this ion is surrounded by water because this is hydrated. Okay, D in ionized water. So it will be dehydrating with water. So the finally the formula of the complex ion would be CrH2O6 and 3 plus because water has no
Hmm.
charge. So
Yeah.
overall charge would be due to the chromium. Sodium hydroxide, again the same thing that we were doing in the first past paper 2025 March. Sodium hydroxide solution was added slowly to the complex ion solution until a solid Q formed. The solid was then separated by filtering under reduced pressure. State the formula of Q. So remember, it would be solid, okay? Because as a result of
Hmm.
filtration, we have to separate the solid. So state the formula of Q. Solid means there would not be any of the charge on that compound particular. This is
Hmm.
the hint for you because whenever they are asking to write down the formula of the solution, solution means it's soluble and it would be in ionic state, so they are saying that it's solid. So I am supposed to write after the reaction with sodium hydroxide when it would be reacting with NaOH, so it would be forming chromium hydroxide. Chromium hydroxide. You can also write down this one, and also you can do in this way.
Won't it be OH6?
CrOH6. No, no. OS add it slowly to the complex ion. If you remember, we were doing the two conditions,
Hmm.
few drops and excess NaOH. Remember, in the presence of few drops, so not all of the water would be substituted by the OH ions,
Hmm.
but instead of all, we have to substitute like only the three OH ions.
Hmm.
Okay, so CrH2O is gonna be 3 and OH 3. So it would be like that. What's the overall charge? No. Okay,
There's no
because
overall
chromium is plus 3. Chromium is plus 3 and one OH is minus 1. So
minus
there
three.
are 3. So
Yeah.
minus 3 plus 3 cancels each other. Draw a label diagram of the apparatus used to filter under reduced pressure.
It's like a conical flask, and then on top of a conical flask, there's that um like that filter sheet, and then you have to connect it to um there's a Like I don't know the
Like I
name.
can do this one.
Yeah,
This is the
yeah, conical flask.
conical flask. And here is a vacuum pump.
Yeah, vacuum pump. That's the name I'm searching. Yeah, vacuum pump.
And then we have a funnel. On that funnel, we have a sheet of filter paper.
Yeah.
This vacuum pump is going to increase the vacuum environment, is going to decrease the pressure. So of
Mm-hmm.
course it will be this conical flask is going to suck all the liquids leaving behind the solid. As compared to the normal filtration apparatus, this is going to be faster as compared to the others. Give two
Yeah.
advantages of filtering under reduced pressure compared to gravity filtration. You have to remember the simple one filtration, it was gravity filtration. So number
It's
one is
slower.
that it's faster, of course.
Yeah,
It's going to be faster.
and
And what
more
would be
filtration would be better. Like more comp how do I say? Uh, Filtrate is more pure.
more pure, or basically, when you will be doing this process, so all of the water is sucked by that vacuum pump. So means that your what can I say? We have two things like residue and then we have filtrate, isn't it?
Hmm.
So
Hmm.
residue, that would be your solid that is to be separated from that solution. So it would be easy to dry. It would be
Yeah.
easy to dry. So of course, I can say that it would be you can get more amount of your residue and you can remove more of the soluble impurities. I can say
Hmm.
this one as well. Okay. So in other words, yeah, it's more pure. So more soluble, more soluble impurities can be removed easily.
Yeah. Okay.
What you would see in this reaction, of course, it's of 2 marks. Then we have to see the product, any of the colored transition metal we have, any of the colored compound we have. So I would see that particular. So we have in the product side uh, Cr2O72 minus. Okay. Uh, what's the color of that?
This is dichromate orange, no?
Yeah. Okay. Dichromate is orange. It would be a solution or it would be solid. Hmm?
Solution, right?
Yeah.
Mm.
And then what we are supposed to write for another mark?
You have to mention that the color goes from purple to wait, what is solid Q? I don't remember what is solid Q.
They're saying a sample of solid Q was added. So we are not supposed to do anything for that one because we have this solid as well. And
Oh,
this is the solid. So also we are not supposed to write down the color of that one. So we are supposed to write that whenever there is a chemical reaction, so the amount of reactant decreases and the amount of product increases. So I am supposed to write solid. that is MnO2 will disappear. And then orange solution, we have to see that.
Okay.
Okay.
Yeah.
So because they are saying the final like during the reaction, what you will observe.
Hmm.
So solid MnO2 will disappear and orange solution of Cr2O72 minus is formed.
Hmm.
Excess sodium hydroxide solution was added to a second sample of solid Q, forming a green solution. Like means that it's going to have chromium, isn't it? Because chromium is going to be green. Give
Hmm.
the formula of the complex ion that forms the green color. That forms the green color. So I told you we have few drops of sodium hydroxide and then we have excess sodium hydroxide. Now this is the case of excess. So then what we are supposed to write in this?
CrOH6 3 minus
Exactly. CrOH6. And what's the charge?
3 minus.
3 minus. Because chromium, this is plus 3. It's going to be minus 6. So minus 6 plus 3 is minus 3.
Yeah.
Name the type of reaction that has taken place. Mhm, mhm.
Hmm.
This is very good question.
Um, not sure. Not sure. Substitution?
Sorry?
I don't know. I don't know this. I don't know.
Okay. Uh, okay. If you remember, I told you regarding the ligand. What is ligand?
Hmm. Ligand is a.
You can relate it. Ligand is equal to nucleophile. Ligand is equal to nucleophile. They are lone pair donors. So generally in a complex compound, we do have a ligand substitution reaction, but this is not a ligand substitution reaction, because it's going to react with sodium hydroxide. So,
Yeah.
if I tell you this one, this is chromium and this is H2O. Of course, we have six water molecules around the chromium, and NaOH is going to react with that. So NaOH means that it's going to give its OH negative ions because it's a base and it's a proton. It would be attacking on that proton. It would be taking away a proton from the water. So if that H2O is going to lose its proton. So what would be the final product? CrOH, isn't it? Isn't it
Hmm.
CrOH? So I can say that this is acid-base reaction. NaOH is acting as a base. Water is acting as an acid. Why? Because water is going to donate its proton.
Water is amphoteric.
Yeah,
Yeah.
exactly. So I can write its acid-base reaction.
Hmm.
Cr,
Sir,
yes,
can you quickly
positive.
go through deprotonation reaction, ligand
Deprotonation is the
exchange,
same.
and
Deprotonation means that when a substance removes its proton, just like this chromium, H2O6. Like it's not chromium like there would be any of the metal, copper, chromium, nickel. Most of the time we have these three cases. So
Hmm.
whenever water is going to lose its proton, so means that I can say it's a deprotonation, or I can say it's neutralization, or I can say it's an acid base reaction. Okay.
Yeah.
And when let's suppose sulfate ion, it's a ligand because it's going to have a negative charge. It's going to displace OH, it's going to displace any of the negative ion. So then I can say it's a ligand.
Hmm. But it has to have a lone pair, right? Sir? Sir?
Wait, wait, wait. It's updating. That's why it's muted. Wait.
Okay.
Okay. Now we have question number 2. This question is about synthetic dyes. The compound 4-chlorophenol is used in the synthesis of a dye called solvent orange 86. Okay, okay, okay. A student suggested using iron as a catalyst. Okay, in step one, explain why it is not needed in the reaction with phenol, even though chlorination of other aryl compounds such as benzene require this catalyst. Good question. Then what
Phenol
you
is
are
more
supposed to write
reactive than the
exactly. Good,
like,
good, good. Why phenol is more reactive?
due to the OH group.
Why?
I don't know.
What the OH does?
OH. I don't remember this. Like I remember because I did the exam, so like this small coming in my memory. Don't
Basically,
remember.
OH is electron donating group. OH is electron
Hmm.
donating group. Initially, this ring is going to have three double bonds, means that three double bond means it's going to have six electrons. When OH is going to
Hmm.
donate its electron to that benzene ring, so means that in the benzene ring, the number of electrons are going to increase, so the ring becomes more negative. When the ring becomes more negative, so electrophilic substitution will be very easier. No catalyst is required. The reactivity of the ring is going to increase. That's why it doesn't require any of the catalyst when there is any of the electron donating group is present on that benzene group. Okay, and we
Yeah.
have some other groups as well that are called electron withdrawing group. In the presence of that group, the reactivity of that ring is going to decrease, so then we have to require more stronger conditions as compared to the normal one. Okay,
Hmm.
so that's why I'm supposed to write um, lone pair of OH is lone pair of oxygen in OH group is delocalized into the ring so which increases electron density
Non-para.
of the ring.
Hmm. Non-para. Hmm. Delocalized into the
As
ring.
a result, ring is more reactive towards electrophilic attack. So that's why catalyst is not needed. That's the reason. The
So
student
non-para
suggested
oxygen
using the
OH group.
apparatus shown to carry out the heating under reflux. Okay, 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 okay,
Wait one
okay. There
second.
are
Can you
two
go up?
mistakes. Yeah, this one.
Yeah, the previous question. Yeah.
Yeah,
Mm-hmm. Non-para oxygen OH group is delocalized into the ring, which increases electron density of the ring. Non-para oxygen OH group is delocalized into the ring. One, what does it do? It increases the electron density of the ring. So more reactive towards, more prone to electrophilic attack. The lone pair of oxygen in OH group um, delocalized into lone pair of oxygen in OH group delocalizes into the ring, causing an increase in electron density of the ring. Um, then, as a result, it's more prone to nucleophilic attack, electrophilic attack. Yeah, fine.
okay. Now, what are the two mistakes in this?
Identify that. Can you go up? What is the main question asking? One error is you should use a pear-shaped flask, right? With anti-bumping granules. This is reflux, right?
Yeah.
Yeah, so you should use a pear-shaped flask with anti-bumping granules.
Okay. And then
Then the water in, water out should be switched.
yeah, exactly. So the direction of water is wrong because water in should be in the lower side and the water out should be in the upper side, because water goes against the gravity. So it would take time. When it would be taking time, it would be a more point of contact with that surface of that condenser. So the surface of the condenser becomes colder. So the
Yeah.
so the process of condensation will be very smooth. So that's why. So number
Hmm.
one, you should assume the apparatus is okay, 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 okay. So mm, direction of water is wrong. So which due to that, due to that, I can say there there won't be there won't be effective cooling process. And then number two is that uh, you can see about the condenser. You can see about the condenser. Uh, Condenser should always sealed, okay,
Okay.
so that all the vapors can go, cannot you can say uh, cannot be removed from the condenser. We can say that the pressure would build up. Okay, so basically the thing is that
Hmm.
you can see where the thermometer is placed. Okay,
Hmm.
or like you told that the granule should be there. Why the granule should be there? Because there would be smooth boiling. And if we are not going to have a anti-bumping granules, so the boiling is not very smooth. Okay, so
Yeah.
that's the good point to write down. So there are no any anti-bumping granules in this. So there is no anti-bumping granules. So due to this, boiling will not be very smooth.
Hmm.
Diazonium ions can react to form azo dyes. The ions are formed as shown. Okay, 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 okay. Give the systematic name of HNO2. What's the oxidation number of nitrogen in HNO2?
Uh, Oxidation numbers, so 2, -2, 2, -4, 4, 3. 3, right?
Yep. So it's called, okay.
Yeah.
You're
Nitrous
also
oxide.
supposed to write it. It's nitrous acid.
Nitrous acid. Okay. Hmm. Nitrous acid.
Because for the lower oxidation number, OUS is used, and for
Hmm.
the higher oxidation number, IC is used. Like in the
Hmm.
normal formula of nitric acid, what was the formula? HNO3. In that, nitrogen is plus 5.
HNO3.
Okay, so
Hmm.
that's why. State why the
Hmm.
HNO2 is formed when required in test tube A rather than bought from a chemical supplier.
Hmm. Mm, it is
The thing is that the thing is that we
high.
have two ways. We have two ways. The first way is to purchase this chemical from the supplier, and another way is to do is that during the chemical reaction we can form the particular reactant and we can carry out the chemical reaction. So the thing is that how
Hmm.
can I take this thing from the supplier, as we know that this is very reactive. Very reactive means that it's highly unstable. Once it's formed,
Hmm.
so so in the next few seconds it's going to decompose. It's going to decompose. So that's why during the chemical reaction we are going to form it, and immediately we generally use this and it's used up, of course. So I can say
Hmm.
that HNO2 is uh, unstable. Explain why the test tubes in step 1. Step 1, the two test tubes containing the reactants are left to stand in ice water baths for 5 minutes as shown. Okay. Explain why the test tubes in step 1 are left in an ice water bath for 5 minutes.
Hmm.
It's a
Which
very
test
good
tube
question.
you are?
Yeah, this one. Because they're talking about the diazonium salt formation, and it's from unit 5. Basically, this is organic nitrogen compound. So we must know the reactivity of the diazonium salt. Why? As you can see, this is the diazonium salt, and till step number 1, the diazonium salt have been formed. So of course, we are
Hmm.
going to decrease its temperature. Okay, if you
Hmm.
remember the reaction and the reagent and conditions for this reaction previously, so you can relate it in an easier manner. So we always lower the temperature of the reaction flask so that at the lower temperature, the rate of reaction is going to decrease. Okay, all the content of the test tube would be at a lower temperature because at a higher temperature, the diazonium salt can decompose, and when it would be decomposing, it would be giving nitrogen. It would be giving
Hmm.
nitrogen gas. So that's the particular reason we are going to decrease the temperature of that content which are present in the test tube 1. So I'm supposed to write at a higher temperature, diazonium salt decomposes. So to make sure use the minimum amount of hot ethanol to dissolve the azo dyes. Explain why a student carrying out is step number 4. In step number 4, the impure azo dye is recrystallized using ethanol as the solvent. So ethanol is an organic solvent, isn't it? So
Hmm.
so why? It's of 3 marks.
Minimum amount. Hmm.
Like in step 4, what they are doing till step number 3, the impure azo dye is separated by filtering under reduced pressure, the same thing that we have used in the last question,
Hmm.
in a vacuum, like the vacuum pump thing. So they are saying the impure azo dye, like azo dye is prepared, now they are going to separate azo dye that is impure, like that. So now we
Hmm.
have, you can see the precipitates of azo dye formed, and then once the precipitate of azo dye formed, and then in step 4 they are saying the impure azo dye is recrystallized using ethanol as the solvent. So they are saying why a student carrying out step 4 was told to ensure they use the minimum amount of hot ethanol to dissolve the azo dye. Like they have to use the minimum amount of hot ethanol to dissolve the azo dye. The thing is that azo dye, azo dye and ethanol, remember, azo
Hmm.
dye and ethanol, they can dissolve in each other. They can
Oh.
dissolve in each other. The thing is that then you have to take minimum amount of hot ethanol, okay?
Hmm.
Or we can say that when we would be dissolving that in hot ethanol, so only the soluble impurities will dissolve.
Hmm.
Okay. So we can, the main reason to do this is to dissolve the soluble impurities. Okay, and of course there would be insoluble impurities which will be left behind. So again you can do the filtration process after dissolving that particular substance in ethanol. Of course after dissolving, the insoluble impurities will left behind, so you can remove it by the
Hmm.
filtration. That's it. Okay, so it's of 3 marks. Number one, we are supposed to write uh, as both compounds what?
Can dissolve in each
Like
other.
azo dye and soluble impurities. Dissolve in ethanol. So soluble impurities will dissolve fully. Whether you have hot ethanol and whether you have a cold ethanol, like the ethanol which is at room temperature.
Hmm.
So So I can say that azodie is far more soluble in hot ethanol than in room temperature ethanol.
Hmm.
Okay, than in room temperature ethanol. So
Hmm.
that's the reason a student is carrying out step number 4 to ensure they use the minimum amount of hot ethanol to dissolve the azodie. Right, so 3 marks, that's it. How the purified azodie could be dried in step 4. How can we dry the precipitate? How can we dry the precipitate? You can use oven, of course, or you can,
Desiccator.
yeah, desiccator. Yeah, we have, this is a particular apparatus that we are supposed to use whenever we are going to dry the precipitate because there is no moisture in that desiccator. Yeah, you can also write
Yeah.
use desiccator.
So can you go up 1 second to the previous question? Like up.